All right, well, let's kick it off then. Welcome to another community conversation hosted by your Autodesk community. My name is Chris, and I'm going to be your community host today. It's my pleasure to welcome Richard, Jorge, and Matt, who will be talking about Fusion 360 electronics. So just a bit about this series for anyone joining for the first time or viewing for the first time. Community conversations are virtual meetups featuring expert speakers from across the Autodesk community. Sessions range from deep dives, tips and tricks, and live demonstrations on products to roundtables on industry highlights, emerging trends, career stories, and so much more. Very quickly, we always throw up this slide here, our safe harbor statement, which basically says that if there are any forward-looking statements made during this session, they are not to be taken as promises or guarantees. Rather, if you're making any purchasing decisions about Autodesk products, make them based on the state of the software as it exists today only. Before we begin, I just want to let everybody know your lines are muted, but you're invited to turn your camera on if you feel comfortable doing so. We do encourage this to be a conversation, so you can use the Zoom raise hand function, throw a question into the chat, or just unmute yourself and jump right in if you like. We are recording the session, and it will be posted to the event page and on YouTube shortly after the session is ended. So let's do some quick introductions. Like I said, my name is Chris, and I'm the Community Manager for Product Design and Manufacturing here at Autodesk. I've been with the company just a little over 2 years, coming from a background of being a customer and user for about 25 years on and off, using AutoCAD, AutoCAD Electrical, Inventor, Vault, all kinds of things. Former Expert Elite and Autodesk University speaker as well. And with that, I'm going to be quiet for a little while and let the expert speakers take over with some introductions, starting with Mr. Richard. Take it away.
Thank you, Chris. Okay, welcome to our community conversations. Well, yeah, I'm Richard, working for Autodesk since 2016, I guess. Came with the acquisition of CADsoft Eagle to Autodesk, and the time before, yeah, I started in 1994. With Eagle, and I have a background in mechanical engineering, and Eagle crossed my life. I have never heard before it in 1994 and started working for the company, and well, I'm still here. So it was an interesting journey, and the last 6 years were amazing. And yeah, what we now have is Fusion Electronics, and I have never thought that Eagle, the initial product, will change in a way as it is now. So many opportunities, so many possibilities. It's really great to see the Eagle fly higher and higher. That's wrong, I know, but Fusion Electronics, for me, it's always the same, you know. But electronics, of course, is much more involved in the environment. It's not just electronics design. We have a good connection to mechanics, all the things around, but that's something we want to talk, and I don't want to talk all the time, so I hand over to Jorge.
Hi everyone, my name is Jorge Garcia. I came into Autodesk with Richard as part of CADsoft, but I have not been here as long as Richard has. So I came in, I think around 2008, I think. So I've been here more than 10 years, going I think on 13 or 14. So I am a community manager, also a degreed engineer. So I like doing all the electronics parts. I do a lot of tutorials for Fusion 360 electronics. And again, like Richard mentioned, you know, we didn't 6-7 years ago, we didn't know that we could be here and that electronics, you know, under the hood, you know, a lot of it's still Eagle, but it's become so much more than that. And there's so many more opportunities with Fusion 360 electronics than we could have ever had with Eagle. So it's nice to see things moving forward and continue to grow and excited for the future. And with that, I'm going to pass it on to Matt to give his introduction, although he probably doesn't need any, but go for it.
Oh, come on. I definitely need an introduction. So I'm Matt Berggren. I'm sort of chief throat to choke when it comes to Fusion Electronics. I run the engineering teams, and was responsible in no small part for the acquisition of CADSoft, which I had been using to teach students at university. I've taught electronics, I've taught physics. I consider myself more a physicist, semiconductor physics, than electronics engineer. But that's mostly just because the branding of physics is that much cooler. Joking, of course, but I have a long history in the industry with EDA and with ECAD in particular. I joined a little-known company called Protel by an acquisition of another company called Excel Technologies. So I've been doing this since the days of PCAD, and was there and sort of instrumental in the rebranding of the company Protel as the company Altium. Really got out of the CAD industry for a few years, and then was tapped to try to bring electronics to Autodesk. And this has been really a labor of love. So whatever it is about the product that somebody enjoys, gets frustrated with, it's very, very personal to me. And I want to do whatever we can to try to build the best tool that's out there. So I'll leave it with that. I'm curious, from this group, because this is the first one of the Ask Me Anything that I've been on. Should I be nervous?
Nah.
Okay, good.
Nah.
No, you shouldn't.
You shouldn't at all.
Good. I mean, I am truly chief throat to choke, so now's the time to choke the throat, I guess.
So we have Mark. Hi to both Marks, actually. We have two different Marks today. So Mark Behrens and Mark Neuhar. If I've mispronounced that, please forgive me. Feel free to correct me. Before we get started, if there's anything you guys would like to ask us, this is very much an Ask Me Anything. So if you guys want to ask us anything, then we can start there. If not, then we can always go over some stuff. So we give you the floor first. If there's anything you want us to talk about, just go ahead and open up your mic and say hi.
Mark Behrens, I know you must have come here with something that you wanted to say.
Well, I for one, sir, am quite interested in seeing what the capabilities of this software are. I have done some work in Fusion. I use AutoCAD Electrical as every day. My question is, what about the Mac? Can I use Fusion on a Mac at this point, and Fusion and electronics in Fusion and Mac?
Yes, you can. It's a very easy question to answer. Yes, you can.
Cool. So I can download it at home. Thank you, sir. That's what I needed to know.
Perfect.
I'm curious with AutoCAD Electrical, obviously that's got a pretty heavy sort of cable and wire harness bent. I guess no pun intended. What is curious to me, I'm good friends with Randy, who was a PM on AutoCAD Electrical for a bunch of years. And we had a long conversation about sort of integration of PCB and AutoCAD Electrical. Are you using AutoCAD Electrical mostly for wire harness, or are you also sort of at the intersection of PCB and all of that? And obviously the two are pretty tightly linked, but with PLC controllers, it's hard to tell whether or not somebody's actually connecting directly to a board or if they're connecting to a Phoenix connector on the outside of some DIN rail enclosure.
My function with AutoCAD Electrical is doing controls design, meaning basically I'm doing wiring and wire harness detail, cable assemblies to go between specified components, not at the component design level.
Cool. And, I think some of the interface there is really about setting the points of connection or the points of connectivity, at least from my experience with Inventor and AutoCAD Electrical. It was really sort of declaring, hey, this is a thing that you can connect to. And then I know Inventor cable and wire harness would go a step further in, kind of drawing those connections automatically. Are you using Inventor on the mechanical side at all?
No, we have had the competitors, the biggest competitor you guys have in mechanical for 30 years. I fought with these guys to try to get it to come in, and they've said that there's no way it's changing.
Mm-hmm.
It's just, I'd love to do it. And that's why my question on the Mac, because at work, my hands are basically tied with installing software, which is why I need to be able to use this at home and actually work with it and not just say, yeah, it looks really cool, but actually learn. So in using electrical, we've gotten into the point where we can define very easily what a connector is, where it mates to. We extract all our cable documentation. We extract all our pin outs and everything else. It works well, but again, that's been my limit here because of the software requirements.
Yeah, I had to really deeply familiarize myself with it. I did a cable and wire harness design for something that went onto an aircraft carrier, and there were about 17 miles of cable in the system. So it was a lot of wiring. But big nuclear powered aircraft carrier, there's a lot of connectivity, and obviously you got to key everything correctly because you're going to put the cable in the hand of a 21-year-old
Yes.
and expect that they're going to connect it the right way, right?
That's one of the things. When you refer to Randy, I assume you mean Mr. Burnett.
Indeed.
Yes.
The one and only.
I've been to every one of his classes, and I kind of miss him not being there anymore, but still talk to him now and then. Always been very informative, very knowledgeable.
Very forthcoming with information. Yeah. I did too. He made the difference between success and failure on multiple fronts for me. So, hats off to him. I hope he at some point gets a chance to watch this video, because he should know that we're all giving him a nod.
I'll make sure he sees it. I mean, I like Randy despite the fact that he's a Green Bay Packers fan, but we'll
what can you do? What can you do?
Everybody's got a quirk,
Yeah.
Nobody's perfect.
Well, I mean, it's like being a Cubs fan, right? You can keep rooting. We don't change our expectations, right? I mean, it's like a Mets fan, right?
I'm a Lions fan, so I know all about that.
Yes, indeed.
One of the interesting things that I've run into is there's a roadblock actually not using Inventor with electrical, is that I have seen SolidWorks electrical before, and it's really nice to be able to see the 3D wire harnesses, and you can extract all these things. And honestly, some of that to me, it would be helpful now that we are doing high production runs of components and we design AGVs. This is our background. We design AGVs to do everything from move the yard tractor that they build in our plant to missiles that they build in another plant. So there's a whole different world there. But the issue becomes that we just now got into high production, so it's never really been a big push for the automation to speak of, which is kind of why I'm wondering, I want to see what the Fusion setup will do with electrical and see how we can actually look into it. Maybe I can talk these guys into seeing it as a value to add to what we use.
Well, and the Fusion electronics environment, and I kind of draw the distinction only because it's an easy mental model for me, between electronics and electrical. And the Fusion side of things is very heavily focused around sort of PCB from its very origins. So obviously, if you've got a 3D model of a PLC controller, you could bring it into Fusion. But the intent really with the electronics domain is to say, look, we've got some custom electronics as a part of the broader industrial machinery sort of control system strategy. With that, we need to build a circuit board that's going to go into that similar type of enclosure, right? Extruded aluminum, DIN rail enclosure, something, the sort of standard stuff that you would find around the factory floor, or go into a custom machine, right? Something which is being built from the ground up. And I would draw the distinction between that and say the Inventor AutoCAD electrical relationship. And Inventor, unfortunately, doesn't run on Mac. Though I've run it in parallels pretty extensively because my primary machine is actually Mac. The Inventor AutoCAD electrical relationship is really about cable and wire harness being visualized in 3D. And Inventor has the plugins for cable and wire harness that draw directly the 2D point references for various connectors, and then the connector types as well, and sort of those things. And if you've been in any of Randy's classes, he sort of expounds the virtues of that bidirectional relationship between Inventor and AutoCAD electrical. Now, Fusion is more on the mechanical design and electronics design front. So separating, again, just kind of reiterating the separation between electronics versus electrical, it's focused very heavily around custom PCB design. So I guess the question that I would throw to you at the end of that sort of lengthy explanation is, are there custom electronics that you're building, maybe not you personally, but custom electronics that you guys are building that are going into the finished systems? Or is this more off-the-shelf PLC control, the sort of Bosch, Siemens, that type of equipment?
We basically will run with your standard industry PLC equipment at this point. That's our primary operator. We do not do any root level PCB design type stuff.
Okay.
I'm basically very curious about learning that stuff because I used to do work, and this is probably, I've been doing this for 40 years. Okay, about 30 years ago, I used to do some PCB design. Actually, when we did it on Mylar, when we did it with tape.
Yep.
And then do you remember back that far?
I tragically do.
Well, I remember doing PCB design for weld controls on 6x6 foot layouts of PCB boards with tape and the nightmares, but it's primarily for a personal learning experience rather than the industry that I'm in right now.
No, which is great, because Fusion, it should be pretty accessible. And I'm not sure if the other Mark would be interested. I mean, I'd be happy to show off a bit of what we do in the software, but I'm also not a sales guy, so it's not going to be hand wavy.
Well, I think it'd be interesting to see because I can always go online and try to learn it.
Sure.
Through some of the places and various, I did this website thing, but still,
Yeah, Chief throat to choke. I hope this is the insider build, which is a sort of early release. I probably should have launched the production release, so at least then I know that I've got something which is more stable. But here's kind of a relatively simple example of some of the stuff that's possible within sort of the Fusion environment. And this has obviously, a couple of PCBs inside of it. There's a base board down here, which has a couple of connectors on it. Those PCBs are just LED panels. They're RGB LED panels. And those were all designed in Fusion. So I've got an air quality sensor here, which is sort of at the center of all of this. And, I've done a few kind of kitschy things just to make it a little bit fancy. I applied some custom materials to the fronts of all of the LEDs, and then I can modify the custom material so that I can actually make the LEDs light up. But, Fusion is really designed for end-to-end product design and manufacturing. So there's the mechanical design environment, a design environment that we call generative design, which is essentially enabling you to establish a sort of base shape and some parameters around that base shape, like strength to weight, material properties, and things like that. Then letting the software actually recurse over the top of that and solve for possible geometries that satisfy the criteria, whatever the criteria are, depending on the stresses and things like that. Obviously, it's a mechanical design tool, right? So the ability to render something, the ability to animate something, do exploded views, those sorts of things, they're all sort of wrapped up in the Fusion environment. But the electronics design capability was something that we introduced based on the acquisition of Eagle when we did the acquisition back in 2016. And I came on board really with the sole purpose of acquiring it and then eventually doing the integration into Fusion. The intent was very much around the sort of end-to-end workflow that you would apply to a product. So, if I start looking at the individual bits and pieces, every piece within the mechanical design, it's going to need machine instructions. It's going to need to be CNC machined or injection molded. In the case of this, I'm using some edge lit acrylic, so that's going to need to be laser cut. Drilling operations, CNC operations, and they're sort of all captured within the manufacturing environment for Fusion, but then also mechanical drawings is a big component of that. The entry point into the electronics environment is actually under this concept we call an electronic design. And what that is the combination of a schematic, which you'd be familiar with from your days laying up mylar and tape, the schematic, and then the subsequent sort of PCB, and the difference being, kind of the difference between the symbolic representation or the immutable representation that is the PCB. So when the electronic design was introduced, it was introduced, I say introduced because I'm not sure if the other mark has some history with Eagle, but it was really introduced as a way for us to create a sort of loose coupling between a schematic document, a circuit board document, and then ultimately the 3D representation of that. So what we've done is try to bring all of the pieces together and do that in a way that was sensible, so that synchronization between those varying pieces and things like that could all sort of be handled automatically by the system. Now, this is a schematic editor. So when you open up the software, you're going to see a new from electronic design that's going to create a sort of blank environment with no stub schematic or PCB in it yet. And if you wanted to get started, then you can either select, I want to create a new schematic, or if you have an existing one, you can reference an existing one. And this is actually, it's sort of a little known thing. Actually, I just sent out a video to my team talking about reusability, because it's so foundational, this idea that these days, especially, 30 years have passed, with microprocessors, microcontrollers, embedded systems, the analog, no pun intended, is to PLC control. So much of the problem is actually moving into the software domain. So the fundamental unit, which might be a microprocessor subsystem, like say that base board for that I use for the air quality sensor, the schematic may actually not change, but the PCB may actually be a completely different form factor, completely different outline. And so we wanted to create this kind of loose coupling between the different assets. The intent there being to enable you again to reuse these things. And if I sort of go all the way to this other design that I have, and here's the schematic that I linked. This is the other version of the board, but I linked a schematic to that electronic design. When I double click on that schematic, I've got all of the functional circuitry, but I don't yet have a PCB. What this enables me to do then is take something at a version, let's say this is, I don't know, version 81. It seems I spent way too much time on this, but every save triggers a version. And then go through the library of components and place additional parts. So, if I dig through my library and say, well, I'm looking for an op amp and I want to place an op amp in some particular package into the design. And I'm an old school analog guy, so this gets respect from me. The placement of those parts in the schematic introduces them into the design with a particular 3D model as well as a 2D model. Try to keep all of those things sort of collected together as a single library asset. But when I switch over to the PCB, unlike the previous version of the board, which was round, I'm introduced to, hey, I've got a totally different PCB now. It's got a lot of other, or it's got, all the components outside of the board. And then, fundamentally, the job of the electrical engineer, and probably the single biggest motivation for me to call myself a physicist more than a double E these days, is to place and route components around the board and, decide on what the form factor of the board is going to be. So, adjusting board outlines and so on and so forth. But it's really the tight coupling between this 2D version of the board and the 3D version of the board that was one of the most interesting things for me coming into the company. It opened the door to the idea that whatever way I slice it, either the mechanical design can drive the 2D board construction, or the 2D board could drive the mechanical design. And it shouldn't really matter, because if we do it properly, the 2D board is the source of truth. That's where you're going to generate manufacturing files. But the 3D board, it's just a view. For all intents and purposes, just another way to view the same information. So, I can adjust the board outline in 2D, but I can also generate a board in 3D, and it's computing the board right now. You can see it down here in the lower right-hand corner. But I should be able to work sort of from any direction. I should be able to build a 3D PCB, which is linked to an enclosure. So, building a simple enclosure and saying, hey, on the enclosure front, I'm going to draw an outline that is, something maybe a little bit more sophisticated than the just box with a shell on it. And this is using the sketch environment in 3D. But from that sketch environment, I can do exactly what you would expect, the sketch and extrude sort of thing that you would expect in a finished design or a mechanical design tool. Shell it, say, hey, I want it to be, 0.1 inch shell around the outside of it, make some changes to the sketch, things like that. And all of these things, because it's mechanical design, they maintain a level of associativity. So, if I needed rounded corners on something, because, hey, I don't want my customer to grab the sharp edge of machined stainless or machined aluminum. I can make the modifications that I want, and in making the modifications that I want, I got zoom right over the top of my panel over here. Those modifications, the changes, those sorts of things, they're all propagated through because of the mechanical timeline. But what distinguishes the tool is the fact that that mechanical timeline, it's really preserved throughout the life cycle of the design. So I can take something like this interior shape here and project that geometry so it becomes a sketch. Once I've done that, that geometry becomes a sketch, and then I can say, well, from that geometry, I want to build an offset, and that offset is going to be 0.02 inches, because the board shape needs to fit inside of that, and I've got to account for machine tool clearance and those sorts of things. From that, I can actually then say, finish the sketch and do something as simple as, I want to create a PCB, but I want that PCB to be associative to the enclosure. So save this, give it a name, relatively simple, select the profile on this. And then from there, I can sort of set the X and Y axis. If I want to pick this as my X axis, and then, from here, I've got the line going maybe the direction that I want, maybe not the direction. I can flip the X and Y axis, set the origin of something, maybe I want it down sort of in that corner. When I do that, it generates a PCB board shape. But again, the intent here is to try to synthesize all of those capabilities. So if I take that PCB board shape and just say board outline, I can then likewise from the 3D PCB link that back to whatever the asset is that I had just created. So if, I just created this PCB, it's called R301, I'm going to save it and give it a name so that way I can target it and say, Alt as an example. Come back over to my board outline, and when that thing has a name attached to it, it gets a version number on every save. We maintain all of those different versions, and then we allow you to selectively choose, well, I want this version of this thing, that version of that thing, branching kind of at any point and saying, well, this is the product, we're going to go to production, but then we're going to make some ongoing revisions, changes, modifications. And I think the save on this is hanging on my version of it, but let me just give it a second because I'm also on Zoom. But it's, it's really trying to kind of bring all those different pieces together. I shouldn't have used the insider build, I guess. And integrating the functionality that is really central to what Fusion's sort of talk track is, its narrative. As I build the various enclosure bits, and let me see if I can force this to be in a good state. This is a point where we pause all of the conversations. And look at that, Richard took off just at the time that this is let me see if I can, I don't know that I want to kill it yet.
Yeah, play around with it. So maybe it's the insider build. That could be.
Well, yeah, it's very much.
Yeah. But actually, talking about insider builds, it's very interesting. So if you if you want to try Fusion and get insight into Fusion before it is released, then join the insider program. It's really great because you have usually you have 3 weeks before release, you get the first insider build, and that's really nice because you also have contact to the dev team. We have some people really monitoring your if you have questions, posts, comments. So it's really nice to be there. And actually, we have a lot of people in the Insider program, but we need more electronics people there. And everybody who is interested, please join it. So it's for free, and just try it. So I think
into the chat for anyone who's interested.
yeah, very good.
Mark
Okay,
or Mark.
cool.
Thanks, Chris.
Yes, like it,
Thanks,
I
Chris.
would be just a pure rookie in it myself, to be honest with
Okay.
you. However,
That's fine, Mark.
it wouldn't hurt to have the resources available to ask the questions, like how do I and why did it just blow up on me, or how did it work so well, kind of thing.
Of course. And I live on the forums generally. So if you go to the forums and you post a question on electronics, usually you'll get a response from me or from one of our other very active users. So we have a good community. It's not like sometimes in other programs where you'll post something, it'll just sit there for days on end. We have enough mass of users and of staff that you'll usually get a response in a timely manner.
If you don't already know him, Mr. Behrens is one of our expert elites.
Okay, cool.
So
electrical world. So he's familiar with.
he knows the deal.
He knows the deal.
Okay. Sure.
I post here and there on the community forums as well, so you may have seen my name probably in
Maybe.
very bad reviews, but that's okay. We won't go there.
Well, nobody ever goes to the forum to tell me how great of a job I'm doing.
That's true. Yeah.
You know,
Actually, yeah. Talking about forums, we have some questions from the other Mark is joining. Maybe. So I just closed my browser window. That's very nice. Oh, yeah, there's one about the documentation. Or you have an idea, where do I get documentation? So actually, there's no book about fusion electronics. That's true. So there's Eagle had a manual, that's true, and we don't have a real printed book. Maybe just Chris, you had the safe harbor statement at the very beginning. There might be a chance that we will see a book for fusion electronics soon. We have an expert elite. He really wants to do a book on his own, and it will be probably the first version will be in German language as well. So, but this will take some time. I guess not this year, of course, and even not next year. I'm not sure, but yeah, there's something in the works, but it will take some time.
Yeah, and in the meantime, since everything in Fusion tries to point, to an online resource, we have a dedicated documentation resource within the company, and he's been doing a great job. So most of the commands are all documented with all of their syntax and options, as well as some good tutorial information. So if you're within Fusion and you click on the question mark, it's going to take you to the different help options. You're going to go to learning and documentation. If you go to product documentation, it's going to take you to a page with all of the Fusion documentation. There's a section for electronics, and everything that is available for electronics documentation-wise is there. And the section that I tend to refer to the most under that is if you go into reference, you're going to find there's an electronics command line reference that covers all the commands and their options. So
do you mind sharing
share
the screen? Yeah.
Yep. So they can see the full layout. Okay, here we go. So if you notice, this is the website right here.
Yep.
And then you'll see an electronics section. And then under electronics, you'll see reference, and then their electronics command line reference. And you'll have all the commands, all their options. It's all here. Additionally, we have all of the user language documentation that's used to be in Eagle. That's all here as well. So everything that was in the help in Eagle is available now within Fusion 360. And then if you go outside of these sections, then you have workflow sections, schematic design, you have tutorials. You have basically parts that were the manual, obviously updated for Fusion. But at this point, pretty much everything documentation-wise that was available for Eagle is available in Fusion and more. The key is just seeing that it's on this website is basically the thing right now. We definitely get the appeal of the book idea. And like Richard mentioned, there's something kind of more formal book-wise in the works, but it's going to take some time.
Yeah, right. Yeah, I think that's the best place to get information on Fusion, and the reference section is really, I think it's everything in it, and I think it helps.
Yes, we could add more links.
That's true.
If you have
For
a
sure, yeah.
specific section that you'd be interested in, or we could pass that along to Bill, and he can make it. Bill's our inside resource for this. If you have specific sections that you're missing or information that you can't find, let us know. You can post on the Fusion 360 Electronics forum, and I'll look into it and see if we can get some additional links made available, or we surface them a little bit better, so it's easier to find.
This brings me to another topic. You mentioned the ULPs in the reference section there. Mark has another question about he's missing some debug features for ULPs. How is the situation with ULPs in general? That's my question now.
So since we have Matt here, I'm going to go ahead and put him on the spot.
Yeah.
Excellent. Thanks, guys. So, the vast majority of the ULPs that existed in the software still exist and still work. At the sort of functional level, what a ULP does is implement the same thing so it's sort of ULP language gets translated to script language, gets executed against a command processor. So most of the ULPs work unless we change to command. So, it's in those cases that if a command had changed, we added some additional options, maybe they're required options. Some common cases are we fundamentally changed how polygons were done. And in those cases, we went back through and actually manually updated all of the ULPs to try to make sure that the ones that we needed to support were supported. From a debugging standpoint, my hope would be at some point that we actually replace ULP with something. That Jorge has asked me innumerable times for Perl.
No.
I'm joking. But most of the scripting languages in software like this, they're actually the way that we do automation testing. So the scripting languages, regardless of what package you use, if it's Altium, it's what's called Delphi script. If it's OrCAD, it's TickleScript. If it's Eagle, it was ULP. And SCR files, which SCR files are just a way to approach the command line in the software, as opposed to having to do something directly. So for the other Mark, if you're familiar with AutoCAD, there's a command line in Fusion Electronics. You can type a command, it puts you into a command state, and then you can start doing things within the command line. As far as the ULP stuff is concerned, we did some work already on modifying the ULP language and exploring what it would take to implement the ULP language as Python. I have to tell you, once we got into that code, it was a much bigger, sort of uglier problem than anybody had hoped. But any of the commands that you have, and to the question of debugging on ULPs, I would want to know specifically what you'd like to be able to do, because we've kicked around a few different approaches to it. Things like building a Visual Studio highlighting, not Visual Studio, but Visual Studio Code highlighting option, and sort of a combination of those things. I think from a debugging standpoint, as a software engineer, my other part-time job, I would like to be able to do things like set breakpoints and evaluate the state of objects and common things like that. What specific kind of debugging capability would you guys want to see? And I guess this is maybe more broadly the whole group.
So, sorry, Matt.
Go ahead.
So if it helps, Mark, as of today, we do have syntax highlighting for Notepad++ and for the Genie editor. We do have that available. And I made a small debug framework. I mean, it's a joke. It's nothing more than basically printfs, but it's better than nothing. It's kind of, I ended up making it when I was working on the import DXF UOP. It's not included with Fusion, that little framework. But basically what it does, it allows you to just insert at different points in your code. You can put a small dialogue, and then it'll show you the value of whatever variable you want to check out. So that's what we have today. It's very rudimentary, but I recognize that it's not anywhere public facing. So that's probably something that needs to change to make it more useful.
Yeah,
I'm not sure if you can hear me. Yes, that's a problem. If I use ULPs, for example, for extracting bill of material or something like that, and you go through all packages or parts, there's sometimes you have the problem that not all parts are in, or you are in another area, so that the output doesn't fit to your expected result. And that's what I'm doing what you showed, what you have showed there. You make a printf and then you examine a text file or something like that. But that's really
it's not enough.
It's not really nice. It took a long time, and yes, even highlighting with I write ULPs now with Visual Studio Code. It's working, and when I then make a text file, I use Notepad++ because he sees, okay, there's a new version of the file, and then you can examine what you are doing. Would help if there's something similar inside Fusion. So let's see what's possible.
So I'm a big believer in the fact that you're either pregnant or you're not, right? So I would like to add a higher quality text editor just in general, and then also a more direct binding to tools like Notepad++ or Visual Studio Code, where the syntax highlighting is just bundled by us, because we know the syntax. It's really on us to keep those things going and to kind of keep them alive. I think one of the big fears when we did the integration with Fusion was, well, if Fusion is all about ease of use, then, I'm nervous about you guys getting rid of the command line or getting rid of ULPs or script files or those sorts of things. And, I'd spent enough time in the Eagle community, both as a professor as well as a user, that I recognized pretty early on, and I think this reassured both Richard and Jorge when I'd come on board, that we have to preserve some of those things which allow people to take control of the tools and drive the tools the way that they want. And not all of that functionality should be built by us. It should be built by a community of people. Fusion today actually has Python API that allows you to control everything in the Fusion environment. really any of the modeling features. And a great example of that, which is sort of not well known, is I mean, it's well known as far as users use it all the time, but the package generation tools that we have in the library editor will create obviously a 2D version of a footprint, a 3D part, even do some things like standoffs and LEDs and those sorts of things. Every one of these is actually a recipe that is created using the Fusion API and implemented with Python. And those Python scripts are actually bundled as a part of the Fusion installation. So we create, in this case, a footprint, and we create a 3D model, but we do that according to the IPC specification. So the part can actually be inserted, it's at the right orientation, those sorts of things. And what we've done with that is also expose all of the parameters that the IPC calls out for package parts, so that people know precisely how we resolved certain things based on the inputs. If you've ever used a footprint generator, the IPC, and for the other mark, that's an Institute for Printed Circuits. They're kind of the standards body for circuit board design standards. That group puts out a document which basically says, hey, when I place this part on the board, and this was something that you had to figure out with Mylar and tape and method of exhaustion, the size of the landing area on the board, that what we used to call the decal, for the metal pin to make contact needs to be of a specific size. So that way you get a good solder joint, but you don't have so much solder that as you get into finer pitch parts, that the part starts to float, right? It starts to drift during the reflow process when you send it through an oven. All of these package scripts, including how we calculate the IPC definition for what the size of the pad should be, as well as how we calculated the 3D model, they're actually bundled in the application directory, and they're Python. So, there's good precedent for us to pursue Python as an approach. Jorge will be absolutely thrilled if we do. We did some work on it, again, kind of keeping with the safe harbor thing. I have hesitated to call that work complete, because some of the interaction is not really there. Some of the commands are not really fully baked in the way that I would want them to be. So we would have to do some more work to finish it. But what this produces by way of that package generator is the 3D asset and the 2D asset. But doing that in a way in which, the 2D asset represents a solderable area that has to follow an industry specification so that we can do machine assembly. The 3D asset represents, well, the WYSIWYG geometry of the part itself. But that 2D geometry is derived from that standard and has all the same parameters that the IPC dictates. So I think we've done some work there that sort of blazes the trail for some of these things, because to generate this 2D geometry, we would obviously need Python interacting with Eagle. But we haven't, there's a proliferation of different workspaces in electronics, schematic PCB, a symbol editor for the schematic version of the part, a footprint editor like this for the 2D version of the part. There's just a lot of surface area. So I think it's something that we should do. If we did it with Python, then definitely we would just bundle it as a Python library, and all the syntax highlighting and rules would come from Python. So now, Mark, you had asked a question about documentation. There is quite a bit. I think, Jorge, you mentioned some of this earlier. Maybe you want to just, so everybody kind of knows where to start. Do you want to share your screen and just point out where the documentation is?
Yep. I think actually Chris also put in the link. So here's the link for the reference. So I'm just putting it in again. Now, are you asking Mark about documentation for all the Python stuff that Matt's mentioned? Because that's all safe harbor. Like, I love safe harbor because of that, because it's not really publicly available. It's something we did internally. Is that what you're asking for, Mark? Let me see if he...
Well, the Fusion API is definitely documented. There's plenty of documentation on the Fusion API, but
the Eagle, the electronics application of it is, I think, what he's asking. Oh, hasn't typed anything. You can open up your mic, Mark, if you wish.
yeah, you'll find at that link the electronics documentation that'll get you started with electronics in Fusion. If you're interested in the Fusion API, on the left-hand side of that same page is the programming interface. And that's related to mechanical design, manufacturing, everything that's not electronics. ULP documentation is definitely available. That would be under the reference section for electronics, under what's called user language programming. And there is documentation for that as well. That diagrams essentially how to get started writing your own scripts there. If the aim is to do electronic design, then that link that Jorge dropped in the channel, that's the entry point to the electronic space. And there are some good tutorials getting started, other things like that, that'll help you to kind of just get oriented. I think the biggest challenge for people coming from Eagle is that we introduced this electronic design file, and that's a very different experience than Eagle, where you just created a schematic and a PCB, you put them in the same folder.
Okay. And Chris dropped the link to the Fusion API forum in the chat, I saw.
Yeah.
That's
Okay,
just
cool.
probably a good place to go for any specific questions that might come up when you are, messing around with APIs.
And as I said, that Python script for the package generator, it's the source for that is bundled with the application. It's actually super powerful. When you see how we did it, you'll start to understand some of the structures and how to interact with the core of Fusion, both the modeling kernel, the materials API, those sorts of things.
Well, guys, we are coming up against the end of the hour, so I'm going to suggest that we call it a good session, and I'll wrap up the last few slides here. And
Outstanding.
Share again. So, did I get it? Can everybody see my screen?
You did.
Right. Should
Yes.
say thank you for joining us. So yeah, we want to thank everybody for coming. I think we had an awesome panel today, and thank you, Mark and Mark, for joining us for this one.
Mm-hmm. One quick question, sir.
Yes, sir.
Is Fusion included in the Expert Elite software download?
It should be, yes. I would double check with Maureen, but I believe that it is, yes.
Okay, so I should contact her and ask her to set that up.
Yep, absolutely.
Okay, all right. Thank you, sir.
No problem. So if you do want to become a community conversation speaker, or if you have an idea for a session that you would like to see us do, please take a look at this proposal link. You can scan the QR code, or I'm going to put the link in the chat right now. You can send us your ideas on what type of session you'd like to do or see us do, and someone will get in touch with you soon after that. Just a reminder that this session is being recorded, and the recording will be available shortly after we wrap up today. So We want to see you get more involved in our community. We've got some fantastic resources available for you, and I'm going to share a bunch of those links right now as well. I know, Mark Behrens, you're probably already familiar with all of these, but just in case. Yeah, obviously you can take part in our forums. You can check out our community groups. Take a look at our Community Voices blog, for which Mark Behrens is an author. And also we have our Community Journal blog, which is the blog that we write for you with news and information about upcoming events and new resources and that sort of information. Take a look at our Student Group Hub, and as always, don't miss the next session coming up on Community Conversations. We will be taking a break through December and coming back sometime in January. We are going to be updating our calendar between then and now. So the next session for this team will be, I'm assuming, sometime in January. Jorge, Richard, you guys are nodding your heads. So it's not on the calendar yet, but keep your eyes. I just put the link in the chat, and as soon as that becomes available, it'll get onto the calendar and you can RSVP for it. So with that, thank you again, everybody. I think this was a fantastic session. We had some great questions, some good discussion, and we'll hopefully see you all in January.
Bye, everyone. Take care.
Thank you. Bye-bye.
Bye.
Good evening. Have a good holiday.
Take care.